A boy is standing on a bridge 50 meters above the water level. He throws a ball vertically upward with an initial speed of 15 meters per second. How high will the ball rise in relation to the water level? Then B, how long will the ball take to hit the water surface? So this is under projector motions. Let's see how we can answer this problem. So I'm going to represent this using a diagram. Okay, so let this be the water level. Then I'm going to draw a bridge. So make an assumption, say this is a bridge. Then this boy is standing on top of the bridge. And what happens is that he projects the ball upwards, vertically upwards. So, and that is at the speed of 15 meters per second. So it will go up like that. Now there will be a point where it reaches the furthest point. Now we need to calculate the height from this furthest point reached by the ball to the water level. So we need to calculate the height between the furthest point and the water level. Then remember that the bridge has a height of 15 meters. So the height of the bridge is 15 meters. We need to remember that. So what I'm going to do next is looking at this being a vertical movement, the acceleration here is simply negative of g. Being that we're going upwards and g is downwards, so we're opposing gravitational acceleration. So hence acceleration in the y-axis would be negative g. Now since time is not mentioned, we use this equation of motion used to calculate the speed. Okay, now since we're in the y, we say vy squared. Then this one, the initial will also be the initial for the y-axis, like that. Then acceleration is negative of g, so say 2 times g then h. So the positive has been substituted with the negative. Okay, now this will be vy squared equals to the initial is 15 squared, then minus, this is 15 squared, minus 2 times of gravitational acceleration, which is always 9.8, that is on earth, then times h, which you don't know. Now one thing that you need to note is that for the furthest point reached by a particle, the velocity component in the y-axis is always 0. So at that furthest point, v subscript of y is equals to 0. So replace with a 0, then this will be equals to 15 squared gives us 225. Then minus 2 times 9.8 gives us 19.6. Then multiplied by h. So the negative 19.6 h will go the other side, where the just it becomes positive. So this therefore gives us 19.6 h equal to 225. Then we now divide both sides by 19.6. So giving us our h to be equals to 11.48. Now remember that this h we are finding is the height from the top of the bridge to the furthest point reached. Now to find the maximum height, which is from the water level to the highest point reached, we need to add this value that we've just obtained plus the height of the bridge. So it will be 11.48 to be added together with 15. Thus we get the maximum height. So our maximum height will be equal to, we add the two values, the 11.48 plus 15 meters. So what we get here is 26.48. So our maximum height to be 26.48 meters. And that's how you answer part A of this problem. Okay, now we need to calculate how long will the boat take to hit the water surface from the point of projection. Now, following this trajectory, the total time taken is simply known as the time of flight. And one thing that you need to note is that the time of flight is always twice the time taken to reach furthest point. And at furthest point, V is equals to 0. So we use V is equals to Uy plus Ayt. Now our Ay is negative G. So it will be Uy minus G then T. Now this final velocity is 0 from what we know. So it will be 0. Now when we take the negative gt, the other side becomes positive gt, which is equals to the initial. Then you're going to divide both sides by g, leaving us with t, which is equals to u over g. Now upon doing our substitution, the initial is 15. Then divide by g, which is 9.8. Now our time will be equals to 1.53. Now this is the time taken to reach furthest point. Now one thing you need to know is that regardless of the position of projection, what it is that the time taken to reach furthest point is always half the total time of flight. The time of flight. So thus total time taken will be equal to twice of this one that we've just obtained. So to be 2 times more t. This will be equal to 2 multiplied by 1.53, giving us our final answer as 3.06. And that's how you solve the problem. Thank you very much for watching this video.